So here we have a logarithmic equation with different but similar bases. So the bases 2, 4, and 8, they all can be turned into the number 2. So the base 4 can be written as 2 squared. Let's copy this first. And then this base can be written as 2 squared of x. And this base can be written as 2 cubed of 3. Let's keep parentheses in here so we don't mix what's the base and what's the number part. And in here we are going to use this rule. If you can make some powers like power x and power y, you can move each power right before the logarithm. The one from number part goes to numerator, the one from the base part goes to denominator. Then you can use a simple logarithm log base a of b, which is the power 2 is, it belongs to the base part, so we will move it to the denominator part. Log base 2 of x, the power 2 goes to denominator. Since we don't have numerator part, we can insert 1. Log base 2 of x. And then the power 3 will go into the denominator part as 1 over 3, and we will have log base 2 of 3. So after this moment, this question becomes like the previous examples. So we should get one logarithm in the left, one in the right side. Also, these additional things should go away. So we should put them back into logarithm. But when we put them back into the logarithm, we don't put them separately. Like 3 goes to the base, 1 goes to the number part. We keep them as a rational number, 1 over 3, and log base 2 of 3 to the power of 1 over 3. All of them goes back into logarithm as a rational power. And the first one remains the same, x. And 1 over 2 goes back into logarithm as a rational power, 1 over 2. Then I have sum of two logarithms. I must connect these two so I can solve this equation. So from plus, when you connect, you should multiply them. X times x to the power of 1 over 2. You should multiply the inside parts. Log base 2 of 3 to the power of 1 over 3. After this step, we are able to say that we have logarithms the same. We have bases the same. So the inside parts, which is x times x to the power of 1 over 2, should be equal to 3 to the power of 1 over 3. So it is just like a normal question right now. We should add the power since we are adding, multiplying same base exponentials. So we can insert here power 1. Let's find the addition of 1 plus 1 over 2 somewhere else. We can write 1 over 1 and times 2. It will be 2 over 2. That means 2 plus 1 over 2, which is 3 over 2. You will get here x to the power of 3 over 2 is equal to 3 to the power of 1 over 3. Now we want to find a final result, x to the power of 1 is equal to a number. So 3 over 2 times what expression gives us the result 1, which is inverse of 3 over 2, like flipped 2 over 3. So we are going to take power 2 over 3 of both sides. This is already in here. We keep them inside parentheses, and we are taking the power 2 over 3. 2 over 3. And in the right side, we have 3 to the power of 1 over 3. We will take power 2 over 3 of both sides. So left side, when you have powers, you multiply them. 3 over 2 times 2 over 3 becomes x to the power of 1. And in the right side, you will have the answer. 1 times 2 is 2 over 3 times 3 is 9. Now you have the answer, but you should check it. So the inside parts of each logarithm, they are both the same as single x. Check. So I have a single x. That single x, I have only one case, 3 to the power of 2 over 9, which is a number bigger than 0. So it's okay. We can use this one as a solution.